Hello everyone, welcome to my channel. In this video, I will discuss the molecular orbital theory of oxygen and its related ions, that is O2 plus, O2 minus and O2 minus. So let's start. In my last video, I have discussed why we should consider the molecular orbital diagram without sp interaction for O2, F2 and Ne2, and for B2, C2 and N2 we should draw the molecular orbital diagram with sp interactions. If you are interested, you can go through that video as well. So for O2 we have to consider the molecular orbital diagram like this. Okay, now oxygen has the electronic configuration 1s2, 2s2, 2p4. Okay, so the two oxygen atoms will form the O2 molecule and their electronic occupations will be like this. I have not shown the 1s orbital because I have written here the kk cell in which the 1s orbitals of the two oxygen atoms are involved, forming sigma 1s2 and sigma star 1s2 molecular orbitals. Okay. Now 2s and 2p are the frontier orbitals and those will be involved in the forming the higher energy molecular orbital diagram. Now total there are 16 electrons. Out of that 16 electrons, 4 are already used in the kk cell. So there will be 12 electrons left to occupy the higher energy molecular orbital diagram. So how they will occupy? Like this. Okay. So from the molecular orbital diagram, if we write the electronic configurations of O2 molecule, that will be like this. Sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma 2px2, pi 2py2, pi 2pz2, pi star 2py1, pi star 2pz1. Obviously, we have considered the x-axis as the molecular axis. Now, let us try to calculate the bond order of O2 molecule. For that, we need to know the total number of bonding electrons and the total number of antibonding electrons. So from the diagram we can see that total number of bonding electrons are 10 and the total number of antibonding electrons are 6. The orbitals with the asterisk marks are the antibonding orbitals and without the asterisk marks are the bonding molecular orbitals. So the bond order will be 10 minus 6 divided by 2. So it will give the bond order of O2 as 2. Okay, we already know this because generally when we write the O2 molecule, we give double bond in between the two oxygen atoms. Now, you again concentrate on the diagram. You can see here that the pi star 2py and pi star 2pz molecular orbitals contains one electron each and those are unpaired. So, O2 molecule will be paramagnetic and the magnetism will be equal to the two unpaired electrons. Now let's try to draw the molecular orbital diagram for O2 plus ion. Here one electron is removed from the O2 molecule and O2 plus ion is generated. So let's say this electron was removed. Okay, so there will be one electron short compared to the O2 molecule and obviously in the MO also one electron will be short. This one is removed. So now that there will be total 15 electrons. Okay. And the molecular orbital diagram electronic configuration will be sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma 2px2, pi 2py2, pi 2pz2 and pi star 2py1. Means before the pi star 2py1 all are same compared to the O2 molecule. And the change is here only. Pi star 2pz, earlier there was one electron, now there is no electron. Okay. So here the bonding electrons total will be 10, but the antibonding electrons will be one short compared to O2, and so the bond order will be 10 minus 5 divided by 2, that is 2.5. Now in the diagram still there is one unpaired electron left. So the O2 plus ion will also be paramagnetic, but the magnetism will be equal to the one unpaired electron. Earlier for O2 it was equal to the two unpaired electron. Okay, that is for O2 plus ion. Now let's go to the O2 minus ion, that is the superoxide ion. Here the case is reversed. Here one electron is added to the O2 molecule. So one electron will be extra, means 16 plus 1, 17 electrons will be there. So let's say this one electron is added here. Okay, earlier it was unpaired electron, now it is paired up, and there will be total 17 electrons, and that extra electron is coming here, means pi star 2 py. Earlier for O2 molecule it was unpaired electron, but now it is paired up. So the electronic configurations will be changed here. Pi star 2 py becomes 2 and pi star 2 pz still 1 electron. Okay, now from the electronic configurations we can see the total number of bonding electrons will be 10 and the total number of antibonding electrons will be 7. So the bond order will be 10 minus 7 divided by 2, that will be 1.5. Now you see here that pi star 2 pz orbital still contains one unpaired electron. So like for O2 plus ion, O2 minus ion will also be paramagnetic and the magnetism will be equal to the one unpaired electron. That is for O2 minus ion or superoxide ion. Now for the O2 minus ion, that is peroxide ion. Here 2 electrons are added in compared to the O2 molecule. So the total number electrons will be 18, and those extra electrons you consider like this, means here it is paired up and it is also paired up. Okay, now we have to fill up the total 18 electrons here, and in compared to O2 where pi star 2 py and pi star 2 pz contains one unpaired electron, now these will be paired up because 2 extra electrons are there, and that will make the paired electrons in the pi star 2 py and pi star 2 pz. Okay, so this is the change compared to the O2 molecule, and the electronic configurations will also be changed like that. So this will be pi star 2 py2 and pi star 2 pz2. So the total number of bonding electrons will be 10 and the total number of antibonding electrons will be 8, and the bond order will be 10 minus 8 divided by 2, that is 1. Now in the diagram you can see there is no unpaired electron left, okay, in the molecular orbitals. So the O2 minus ion will be diamagnetic as there is no unpaired electron. Okay, so what we have got from this discussion, that O2 has bond order 2, O2 plus has bond order 2.5, O2 minus has 1.5 and O2 minus ion has the bond order 1. This indicates O2 minus ion should be least stable among all those species. Okay, and the magnetism except O2 minus all are paramagnetic, although their paramagnetism may vary depending upon the number of unpaired electrons. O2 plus and O2 minus has the one unpaired electron, whereas O2 has the two unpaired electrons. Okay, so if we try to write the order of bond order, then it will be O2 plus will be highest and O2 minus will be least. And we know that with the increase of bond order, bond length decreases. So for bond length, the order will be reversed, means O2 minus will be the highest and O2 plus will be the least. And depending upon the bond length, the stretching frequency also varies. The bond order increases, stretching frequency also increases. So bond stretching frequency will follow the order. O2 plus will have the highest value and O2 minus will have the lowest value. Bond stretching frequency or the IR stretching frequency gives the idea about the strength of the bond. Greater the order of the bond, greater will be the stretching frequency. Okay, so this was the discussion for this video. I hope you understood what I have discussed in this video. If you have any question, you can write in the comment box. I will try to answer those questions. Thank you. Thank you all for watching my videos.